Hey everyone, Mr. Fransky here. Today we're going to be talking about synthetic division of polynomials. Synthetic division is kind of a little shortcut way to do long division. Long division, as you know, can be kind of tedious, and this is a quicker way to be able to divide these things and get the same result, but without having to do all of kind of the messy algebra. So let's take a look. Key vocabulary today, dividend, divisor, quotient, remainder, things that we have seen before, and of course synthetic division.
All right. So synthetic division is just a way to take a shortcut for long division. So by now, hopefully you're comfortable with long division. We have a completely worked out long division problem here. We're doing x cubed minus 4x squared plus 2x plus 5 divided by x minus 2. So what remainder theorem told us is since we're dividing by a linear factor here, x minus 2, this remainder, there should be a way to get that remainder without having to go through all of this long division. So what remainder theorem says is that if we plug in positive 2, because if you plug in positive 2, it'll cancel out that negative 2. You plug in positive 2 into this top equation, you'll actually end up with 1. So if we call this top guy p of x, if you do p of 2, you should get 1. So plugging in that positive 2, there's actually a shortcut we can use to get all of these values. And where it kind of comes from is because if you're doing x minus 2, you don't really need the x because we know it's a linear factor. And then these x values, there's a lot of x's going on here, but a lot of the numbers are repeated. See, that negative 2 comes up twice. The 1 coefficient comes up here twice. That negative 2 is there twice. That we brought down the 2, we brought down the 5. There's a lot of repetition going on here. And there's just kind of a clever way and a more succinct way to be able to write this out. So watch this. What we're going to do is this only works for linear factors again. So we have this x minus 2. So what I'm going to do is I'm going to put the 2 into what I call the box. Alright, so I put a little 2 in this little corner here. And now what I'm going to do next is I'm going to list out all of the coefficients of my p of x up here. So the polynomial that I'm taking and dividing by x minus 2, I'm going to write out the coefficients. So my first coefficient here is 1. So that first coefficient is 1 of that x cubed. Next one's negative 4. Be careful you don't drop your negative signs. Next one's positive 2. And the last one's 5. Then I'm going to draw a line just a little bit below those numbers, so I have room to write in that row right there. First thing I do is I just bring that first number straight down to the bottom. So I just bring that 1 straight down to the bottom. Now what I do is I'm going to come up diagonally, and I'm going to multiply by the number I have in the box. I'm going to multiply by 2. So 1 times 2 is positive 2. And then vertically here I'm going to add. And the reason I can add is because over here we had that negative sign. We had the x minus 2, which is why we had to subtract every time. But since I switched it, according to remainder theorem, I can just use that 2. I'm going to actually add these. So 2 plus negative 4 is negative 2. Now I'm going to multiply by 2 again. So every time I go up here, I'm going to multiply by 2. I'm going to multiply by 2. So negative 2 times 2 is negative 4. I'm going to add that to 2. That'll give me negative 2 again. Now I'm going to multiply by 2 one more time, negative 4 again, and that gives me 1. Well, hey, check that out. That's my remainder. So 1's my remainder. And so really what I've done here is I've just plugged 2 into the function that has coefficients 1, negative 4, 2, and 5. And the math behind it is kind of interesting because what I'm doing here is that 1 has been multiplied by 2 1, 2, 3 times, which is where that x cubed comes from. The negative 4 has been multiplied by 2 once, twice, which is where the square comes from. The 2 is just been multiplied once, and then we just added that 5 at the end. So that's why it works to get that 1. Now, this is the coolest thing. This is kind of like a bonus to doing this synthetic distribution, or this synthetic division. And I'll do it in a different color so we can see it. Look at these numbers right here. 1, negative 2, and negative 2. Where do we see those in here? They're the coefficients of my quotient. 1, negative 2, and negative 2. How cool is that? So without even doing any of this, no long division, just in this little nice succinct way, it's called synthetic division, I'm able to get not only the remainder but also the coefficients for the quotient polynomial. So what this tells me is that the result of this is 1x squared minus 2x minus 2. And my remainder is 1. Let's take a look at another example. It does always work. I know it's pretty surprising. It's pretty cool that we can do this. So once again, we have our entire long division written out here. And this is an important point. There's no x term in here. There's no x term. So what we have to do, since there's no x term, is we have to make sure we put in that 0x. So when we do the synthetic way, we have to do the same thing. Now this time notice we have x plus 3. So I could write that as x minus negative 3. So this time in the box we're going to have a negative 3. So put negative 3 into our box. Now I'm going to list out the coefficients of my polynomial up here, my dividend. So I'm going to have 2, because it's 2x cubed. Then I'm going to have a 4. And now this is where it's really important to have that 0. Really important to have that 0 there. So I have a 0 here, because I have a missing term there. And then I have a negative 5. And the reason the 0 is so important is because when we're multiplying, it's very important that we multiply by negative 3 times to get that cube. So we need that extra row. So put in our line here. The 2 comes straight down. Notice that is the first coefficient of our quotient polynomial. Now I'm going to multiply by negative 3, gives me negative 6. Plus 4 is negative 2. There's our second coefficient. Times negative 3 is positive 6. Add to 0, that's 6. Times negative 3 is negative 18. Add to negative 5 is negative 23. You'll notice I usually put this kind of backwards box down there to show that that's the remainder. So that tells me that my answer is 2x squared minus 2x plus 6 with a remainder of negative 23. How cool is that? So much faster than doing the entire long division. So I want you to try this one on your own. So we have another equation here, another division problem we want to do. So if you want to pause the video real quick and just see if you can do this just by doing synthetic division. Alright, hopefully you were able to figure that out. Let's do it together. Let's do it together. So the first thing I'm going to do is I'm going to put into my box. Now I'm going to notice I have x minus 3. So I'm going to put a positive 3 into my box, because that's the number we're really plugging in. Because the remainder theorem says that 3 minus 3 will give us a 0 there. So 3 is the number I want to plug in. Now I'm going to list my coefficients. 1x cubed, negative 2x squared. And now I hope that you guys caught that once again we're missing that x term. So since I don't have an x term there, I need to put a 0 in. If you missed that, it's okay. It takes some practice. And now we have a negative 4. Draw our line in down here. Bring down our 1. Multiplied by 3 is 3, minus 2 is 1, times 3 is 3 again, plus 0 is 3, times 3 is 9, minus 4 is a remainder of 5. So the result of this, the answer to this problem is 1x squared, because I have 1x squared, plus 1x, plus 3, and the remainder is 5. And let's see if that's what they came up with as well. So let's see here. They have their 0x here. Now this is the long division way of doing it. A little bit longer process, but they get the same thing. They get x squared plus x plus 3, which is what we got, with a remainder of 5. I just love synthetic division. It's such a nice, clean way of doing things, and the math is really cool how it works out. So there are a few things that you have to note about this synthetic division method. One is that it only works for linear divisors x minus c. So it won't work for like 2x squared minus 4. So if I'm dividing, whatever I'm dividing by, let's take a look at this one, it has to be in that form. Just x minus a number, or it could be x plus a number. The only thing then is that you have to put in a negative. And that's the second thing that I have here that's worth noting, is you have to always change the sign. So if it's x plus c, you put negative c into the box when you start. If it's x minus c, then you're going to put in the positive c. Next up, the remainder. Remember, this is from remainder theorem. It's p of c. So, kind of a quick way of doing remainder theorem. I know now if I were to plug 3 into this polynomial, the result would be what? Well, it'd be 5, because that's my remainder. So this means that p of 3 is equal to 5. That's kind of like a bonus.
And that's all I've got for you today. So I hope that this was a little bit easier than the long division. Love you guys. That's why I'm here. Have a great day.